Hi everyone, welcome to my YouTube channel. This is Dr. Deepti Prakash. Okay, so this is about the operation of NPN transistor. Now the second question they might also ask the same thing you have to explain in terms of PNP transistor. So here also this is nothing but your unbiased PNP transistor and this is biased PNP transistor. Here also the holes or the majority charge carriers will be emitted into the base and the holes will be collected from the base of the collector. Here also the base emitter junction will be forward biased and the collector base junction will be reverse biased. So for normal operation, that will be the common thing, base emitter junction forward biased and collector base junction will be reverse biased. And holes will be emitted from p-type emitter across the forward bias PB junction into the base, and in the n-type base the holes find few electrons to absorb and float outwards from the base, and the remaining holes will be flowing out via base terminal. Most of them will be drawn across the collector by the positive negative electric field at the reverse biased junction. So this is the operations of BJT, NPN as well as PNP transistor. These are the two basic questions and the important question which might get in any of the one transistor, either NPN or PNP transistor. Next question will be one of the important question, that is describe the BJT currents and voltages. So you can write, this is I'm showing with respect to the NPN transistor. So if I write this NPN transistor, across this collector base junction you have VCB. This voltage is nothing but the collector to base voltage, and this is the base to emitter voltage, and this is the collector to emitter voltage. So you'll have three voltages across these three terminals. So this is how the circuit looks when we are connecting the base. This is base, this is collector, and this one is emitter. So here we are putting one resistor which we name it as base resistor and collector resistor. Then we are giving the supply voltages VBP and VCC for the base emitter junction and collector emitter junction. So these are the currents which you can find out or which you have to deal with in the BJT, that is base current, collector current and emitter current, as well as this, that is a small leakage current due to the minority charge carriers. These are with respect to majority charge carriers, the flow of electrons from emitter, that is nothing but your IE, and few of the electrons will be absorbed in this particular base and flowing out, that will be the base current, and the majority charge carriers which has been collected across this collector, that we emit as this collector current IC. And these are the voltages VBE, VCB and VCD. So with this you can see here the entering current or the current which is emitted due to the flow of majority carriers is the emitter current. So the collector current and the base current are the byproducts of this emitter current. So this we can able to write it as IE is equal to IC plus IB. And this IC we can write it as beta DC into IB. What is this beta DC is? It is nothing but the current gain. this current gain is nothing but the output current and the input current. So output current is IC and input current which you are going to give us I. So this is with respect to NPN transistor and with respect to PNP transistor diagrams. You can write any one of the diagram, either NPN or PNP. So if you take an NPN transistor, the IE flows into the transistor where IC and IB are flowing out. In NPN transistor, IE flows out of the transistor, IC and IE will be flowing inside. So on the whole, you can say the emitter current will be equal to sum of the collector current and base current. So IE crosses the collector and only small portion will be flowing out of the base. So we can tell approximately it will be equal to this, because base current will be very small. Base current will be always in terms of microamps, and these two can be in terms of milliamps. And there will be small leakage current due to the minority charge carriers, which will be naming it as ICBO. Hence we can write this collector current is nothing but alpha DC IE plus ICBO. That is current gain into emitter plus the leakage current. So this alpha DC is nothing but emitter to collector current gain. All these equations will be using it for solving the problems. The entire problems, I'll make one video. Few important problems, different types of problems I'll solve, and I'll be explaining that in the upcoming videos. So this is common base DC current gain, and it might be always ranging from 0.9 or 0.96 to 995. As the leakage current is very small and it is negligible, it can be ignored. Hence we can write this current gain, that is collector current, as current gain into emitter. So you can also write this alpha is equal to IC by, whenever you want to find out alpha, you can use this. Whenever you want to find out beta, you can use one more, done in the next slide. Yes. So you can see, you can write like this by taking that previous equation, alpha DC into IE. IE I can write it as, so IE I can write it as IC plus IB, so that it will be like this. So if you expand and if you are going to simplify, so you can get like this: IC is equal to alpha by 1 minus alpha into IB, or IC by IB, which is alpha by 1 minus alpha. So this we can write it as, it is base to collector current gain, that is beta. Okay, so you can write beta, the base to collector gain, as IC by IB. So beta value is alpha by 1 minus alpha. So it is common emitter DC current gain. Its value typically ranges from 25 to 300, and it can also be indicated using the H parameters. So for you, this much, if you are remembering these equations, the current gain equations, and what is the collector current equation, what is the emitter current equation. So that is all about your voltages and currents of BJT. So that was the third question. So next is, you might also get one more important question, because the BJT we can use with the two applications, that is as an amplifier and as a switch. So how it is used as an amplifier, or how the current amplification is done in the BJT. So how we can start to answer for this particular question is a small change in base current, you can name it as delta IB, produces large change in the collector current delta IC, and also in turn large change in the emitter current, that is IE. Thus transistor can be used for current amplification. If you give a small change in the base current, in turn it can change the larger change, or it produces larger change in the output currents, that is IC. So there is nothing but the current gain can be stated in terms of current level changes beta, which is delta IC by delta IB. This is nothing but current amplification. So the increasing and decreasing values of current may be defined as alternating quantities. So IB is base current, IC is collector, and IE is emitter. The alternating current gain from base to collector can be stated as this. So if you give small changes in IB, it can give you a bigger change, or produces larger change in the collector current. So you can write this circuit diagram, this thing, and you can explain this gain, that is current gain. So if you do so, you can justify for this particular question. Stay tuned to my videos. The rest of the questions I'll be explaining in the next video. Thank you everyone. Do follow my channel and subscribe. Thank you.